What's up everyone, and welcome to Learn with LAM. Today we're going to be going over step by step how to calculate moles from particles and how to calculate particles from moles. The equations that we're going to be using today are little n equals big N over NA and big N equals little n times NA. Now, little n represents number of moles. Big N is number of particles. And NA is Avogadro's constant, which is 6.02 times 10 to the power of 23. But before we go into the examples, for those of you who are having a bit of trouble understanding the concept of moles, let me break it down for you. See, a mole is just a word that represents a number, the same way that the word dozen does. The word dozen means 12 of, and the word mole means 6.02 times 10 to the power of 23 of. I know it's a slightly bigger number, but the concept is the same. So when I say you have 36 eggs, how many dozens of eggs do you have? Did you say 3? Because that's right. And what if you have 2 dozen donuts? Then how many donuts do you have? If you said 24, then you got it, and you already know how to do mole conversions. Let me show you why. The reason 36 eggs equals 3 dozen eggs is because of the same equation we use for moles, except instead of Avogadro's constant, we'll use, let's call it, the dozen constant. I'm going to create some new variables for you just to prove a point. So we now have little nd, which represents number of dozens. Big N is still number of particles. And big ND will represent the dozen constant, which is 12. So if we have 36 eggs, that's the number of particles. And if we want to determine the number of dozens, we're going to use the same equation as we have above, except using our dozen variables. So the number of dozens is equal to the number of particles over the dozen constant, which is 36 over 12, giving us 3 dozens of eggs. And if I'm giving you the number of dozens, so 2 dozen donuts, and I'm looking for the number of particles, I'm using this equation over here. Number of particles equals the number of dozens times the dozen constant. So 2 times 12 gives me 24 donuts. Not so bad, right? So we're ready for a mole example? I'll do them right under the dozen examples so you can see how they're almost exactly the same. If you have 1.204 times 10 to the power of 25 atoms of carbon, how many moles of carbon do you have? Going back to our first equation, the number of particles here is 1.204 times 10 to the power of 25. This time I'm using the real equation, so number of moles equals the number of particles divided by Avogadro's constant, not the dozen constant. And so that is 1.204 times 10 to the power of 25 divided by 6.02 times 10 to the power of 23. That gives me 20 moles of carbon. By the way, if you got 2 times 10 to the power of 47, that's unfortunately incorrect. But that's okay, it's a quick fix. Just make sure you throw a bracket around Avogadro's constant in your calculator and you should be good to go. And now, what if you have 2.5 moles of an atom? How many individual atoms do you have? Well, in this case, 2.5 moles of helium is, of course, our number of moles. As we now know, number of particles equals number of moles times Avogadro's constant. That gives me 2.5 times 6.02 times 10 to the power of 23, which gives me 1.505 times 10 to the power of 24 atoms of helium. And that's all there is to it. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.